So before starting Bresenham's line drawing algorithm, I would like to discuss about the disadvantages of your DD algorithm. Only then it will make any sense of going for another algorithm, isn't it? So what are the disadvantages? So when we studied about DD algorithm, you saw that a jagged line was being formed when we were plotting the points. It was not like for a particular position, like for particular position X, we were having two values of Y, isn't it? For a particular position of Y, in case where your line slope is said to be less than 1, you were having 2 points for your X. So whenever we had to draw a line, in the case of your DDA algorithm, we had to compromise on the precision. That is, we had to round off the floating point values. And that always resulted in lines which were quite jagged in shape, isn't it? So that was one of the disadvantage of your DD algorithm. Now, the second disadvantage, if I say, is if you're making use of floating point operations, you have delta y by delta x, you're dividing and you get a floating value, and then you try to round it off. All these operations are considered to be time consuming and they are costly when compared to other integer operations when they're implemented in your computer architecture. Depends on your computer architecture. So it was considered as more costlier and time consuming when compared to the equivalent integer point operations. So seeing these two disadvantages of your DDA algorithm, we've come up with a new algorithm which is said to be called as the Bresenham's line algorithm. So it is considered as one of the accurate and efficient raster line generating algorithm, and it was developed by Bresenham. What it does is it will scan convert the lines using only incremental integer calculations that can be adapted to display circles and other curves. So here what you have is you have the values like you always increment the value by 1 or you don't increment. That is the way we do it. We don't have any floating point values and we're not trying to round it off or anything like that. We're just incrementing the values. Either we increment the values or we just consider the same value. Now here I'm showing you a small diagrammatic representation of a display screen. Okay. And here what I'll call these pixels, I have got some rows. Okay. I've got some rows and I've got some columns and I've got some columns. Now what are they? The vertical axis, okay, you're the vertical axis here, it is said to be showing you the scan line position. So these rows are actually your scan line positions. That is your vertical axis. And then you have a horizontal axis. Okay, when you go through the horizontal axis from right, like from left to right, you are going to see some columns. You're going to see some columns. And what are these columns representing? They are actually called as the pixel columns. They are said to be called as the pixel columns. So vertical axis is going to give you the scan line and the horizontal axis is going to give you the pixel columns. Now keeping this in mind, we will see that whenever we need to draw a line, whenever we have to draw a line, okay, that is you have to sample at unit x intervals. So you will be always sampling. That is, first you will take this value. Imagine this is the position 10, this is 11, this is 12, this is 13 and this is 14. So you will be sampling at unit x intervals. After 10 you will go to 11 and after 11 you will go to 12 because that is the pixel column, isn't it? So after 11, 12, 12, 13, 13, 14. To decide which of the two possible pixels is closer to the line path at each sample step. That is, now when I draw this particular line, okay, I draw this particular line, I'll give the y-axis also. We'll call this as 10, 11, 12, 13, 14. So when you see this particular line, you can see that this first pixel is fine. It is at position 10, 10. Now when I come to the next pixel position for this particular line, this particular segment of my line, I see that it is not contained in a single pixel position. It is not contained in a single pixel position. It is like it is occupying places. It is occupying the coordinate value that is said to be 11, 10. Okay, it is here in this particular one in my example. It is said to be taking 10, 11, 10 and it is also taking 11, 11. Okay, so this is corresponding to the textbook values that I have written. So in my example, it is said to be 11, 10 and the other value is said to be 11, 11. So I do not know which particular pixel value should I plot. Should I plot 11, 11 or should I plot 11, 10? Okay. To illustrate the Bresenham's approach, okay, to Bresenham's approach, we first consider the scan conversion process for lines with positive slope which is less than 1. So we are going to consider lines which have a slope which is less than 1. That is, you already learned it. How does a line with having a slope less than 1 look like? It will be having an angle which is said to be less than 45 degrees. Okay, it will be having an angle which is less than 45 degrees. So we are going to consider lines which have a slope which is less than 1. Now, pixel positions along a line path are determined by sampling at unit x intervals. That is, how do you do it? First, you take this particular x position, this is x1. Then you will consider the next sampling position to be x2. Then you will consider the next position to be x3. And what is the difference between these sampling points? It is said to be 1. It is going to be 1. That is, after x1, you increment the x1 value by 1 and you get the next sampling position that is said to be x2. And at x2 again you add a value 1, you get the position x3. Okay, so in this example we are saying that let us consider that the left end point of my line is said to be x0 y0. It's said to be x0 y0. And then we are going to step to the successive x position and plot the pixel whose scan line y value is said to be closest to the line path. Now what is this? We understood after once I plot x0 y0, my next plot has to be x1 y1, isn't it? Now whether it is y1 or it is said to be y0, I do not know. But I know that after x0, my next sampling point is x1. So how do I determine which it is? Now in the example that I gave here, see I have plotted the position 10, 10. You can call it as x0, y0. Then when I go for the next sampling point, that is x1, I know that there is an increment of x value from 10 to 11, that is for sure. But I do not know about my y value. Either it has to be y0, that is said to be 10. Either I'm going to plot this pixel or I'm going to plot this pixel. So my y can take a value which can be y0 or it can be y1. So I do not know which one to take. So Bresenham is basically on deciding which particular value you have to take. Okay, that is what has been shown here. So we are giving a small example here, assuming that we have determined the pixel at position xk, comma yk is to be displayed. So assuming that this is the position that I have displayed, next we have to decide which pixel to plot in the column xk plus 1. So in terms of k, we are writing the pixel values. Earlier I had given it as 10, 11, 12. I had given some discrete values. Instead of that, I am writing it in terms of k. Okay, so I have the initial point which is plotted at xk and yk, and I am plotting a point, the next point, it has to be sampled at xk plus 1. So now I have to determine what about my y value. Okay, what about my y value? I know the x value is going to be xk plus 1. But what about my y value? The y value can be, if this is yk, this is going to be yk plus 1. So y value can be either yk or it can be yk plus 1. It's going to be yk or yk plus 1. Now if you look into this, it looks like, it is this particular line is going from between. You can assume, okay, you can assume that this particular line is said to be going through or from between the two pixel positions which are said to be at point xk plus 1 yk and position xk plus 1 yk plus 1. Now this particular position, okay, you can say these 4 pixel positions. I'm going to show it to you. Something like this. Okay, it's going to look something like this. That is, I can call that this particular column is my xk and this particular column you can call it as xk plus 1. You have to assume it, you have to visualize it so as to understand this concept. So you can say that the y-axis, this particular row is said to be yk and this particular row is said to be yk plus 1. So I've already plotted the point xk, yk. Now I need to plot the point that is for xk plus 1. But I do not know what is the value of my y. Okay, this is my value of my y. Okay, so I do not know what should be the value of my y. Should it be yk or should it be yk plus 1? Should it be yk or should it be yk plus 1? So how do I determine the value of y? The value of y can be determined as you can find the distance. Children, you need to find the distance between this point y which you need to plot on the line. Okay, what is the distance of this point? That is the y value. What is the distance of y from the pixel at position which is having a y coordinate value of yk? That let us call that distance to be d1. Okay, and then I need to compute the distance between the point y and the pixel which is having the y coordinate value as yk plus 1. So let us call that distance as d2. Let us call that distance as d2. Okay, so I have got the distance d1 and I've got the distance d2. So what did I say about d1? d1 is said to be the distance. Okay, it is the distance between the points. You can call it as xk plus 1 comma y k and xk plus 1 comma y. Okay, so d1 is the distance between these two values, that is the pixel which is at position xk plus 1 yk, and at this point that is going to be xk plus 1 itself because it is the same column, but you do not know what the value is of y is, so I just simply put it as y. And what about d2? d2 is the distance between the points xk plus 1 comma y and xk plus 1 comma the pixel which is having the y coordinate value as yk plus 1. So d1 is the distance between these two coordinates and d2 is the distance between these two coordinates. Okay, so that is what you have to understand. Then we will see we have to see which distance is large. Is d1 large or d2 large? Or you can say conversely, which is said to be less. Okay, I have to check whether my d1 is less than d2. Okay, or my d2 is said to be less than d1. If the distance d1 is said to be less than d2, what do I have to do? I'll be assigning my y, d1 less anand, that is this distance. So when this distance is less, obviously I'll be choosing the y value of my previous, I'll be using the same y value, that is yk. So my y is going to be the earlier y value itself, that is going to be my yk. Now if this distance, that is the distance between this point y and the new pixel which is having the value y as yk plus 1, this distance is said to be less, d2 is said to be less, then what is the new value of my y? The new value of my y is going to be yk plus 1. It is going to be yk plus 1. Now how do I find the difference? Now I have to see into the mathematical calculation behind the whole process. Okay, I have to find the mathematical calculation behind the whole process. How do I go about it? So to go about it, let us say that you have a line which has an equation of mx plus c. Okay, we have got the mx plus c. Now second, what do? I'll find what is, I have to find this y. I have to find, say I have got the point as xk and yk was my initial point. Next I am going to find xk plus 1 and I do not know what the value of my y is. So I'll just substitute xk plus 1 in the line equation so that I can compute the value of y. Y is equal to, I have my slope, and what is my x here? X is going to be my xk plus 1. You can also call xk plus 1 as your x next. You can call it as x next. And you can call your y as said to be y next. Okay, you do not know what the value of y next is. It can be either yk or it can be yk plus 1. Okay, it can be either yk or it can be yk plus 1. So how do I go about it? So I have written y. I am substituting the value of xk here as xk plus 1 plus c. Okay, so I have substituted and I have kept it. And let me call this as the second equation. Okay, this is said to be my second equation. Okay, now this xk plus 1, what is this xk plus 1? It is actually xk plus 1. That is, you're incrementing the x value by 1. So this can be written as m of xk plus 1 plus c. So I can call this as my second one. Okay, I'll call this as my second one. I hope you have understood till here. First of all, to find what my y value is, I need to find the difference between the two coordinate values. That is, I have two distance values d1 and d2. Okay, so I have to find, is this pixel value closer to the y value yk plus 1 or is it closer to yk? So I have to compute my distance d1 and d2. My d1 is said to be given as the difference between the point, that is xk plus 1 yk, and this point is said to be in the same column, so xk plus 1 comma y. What about my d2? d2 is said to be the distance between this point. This point is said to be xk plus 1 y. And what is this pixel value? It is said to be the coordinate value. It is said to be xk plus 1 comma yk plus 1. So I've got my d1 and d2. Now, how do I assign the value of y? It will depend on which is said to be less. Is d1 less or d2 less? So I'll check if my d1 is less, my y value will be yk. If my this distance, that is d2, is said to be less, then obviously y is going to have the value yk plus 1. That is, this particular position is going to be taken. Now I have just written verbally what I have just written d1 and d2, but how does this computation take place? To do that, first of all, I'll have to consider my line equation y is equal to mx plus c. Okay, as I have to find which is the next pixel position. So of my line, I know the x value, which is said to be xk plus 1. And xk plus 1 can be written as xk plus a simple one. That is, you're incrementing the value, the earlier xk value by 1. So when I substitute that, I get it as y is equal to m of xk plus 1 plus c. Okay. So I'm going to clear this. I need to find what my d1, I have got my d1 and d2. I already told you it is the difference between these 2 points. Okay, this is the distance is d1 and this distance you can call it as d2. Okay, and this was your xk. This can be called as xk plus 1. This is said to be your yk and this is said to be called as yk plus 1. So what is my d1? d1 can be written as this y minus of yk. I'm just taking the y coordinate values because that is more important for me. And the distance d2 is between my y points because x is said to be same, right? So I don't have to find the difference in x values. I need to find the difference in y values. So what about y? Y is going to be, that is the top value is said to be yk plus 1. And from that I'm going to subtract my y. Okay, so this is my equation 1, this is my equation 2, this is going to be my equation 3, and this is going to be my equation 4. Okay, so I've got my 4 equations in hand. Now I've got d1 and d2. Now I have to find which is greater, which is lesser, d1 or d2. How do I find which is lesser? So I have to take the difference between the two, isn't it? I have to take the difference between the two. That is, I'll have to do d1 minus d2. I'll have to do d1 minus d2. To do d1 minus d2, I'll just write down what is d1. My d2 is said to be yk plus 1 minus y. Okay, so that is my d1. Okay, I'm subtracting it from my I'm sorry. Okay. So I have to subtract my d1, I'll be subtracting the two values, that is d1 minus d2, so as to find which is said to be smaller. Okay, so how do we do it? What is my d1 value? My d1 value is said to be y minus yk. Okay, and I have to subtract d2, and what is my d2 value? It is said to be yk plus 1. From that I am going to subtract my y. Okay, now what is this y value here? What is my y value? I already have my y value. Y is equal to mx plus c. Or when you write it in terms of xk, it can be written as y is equal to m of xk plus 1 plus c. Now what I'm going to do is I'm going to substitute the equation 2 in this. I'm going to substitute the equation 2 in this for my y value such that I'll get it as, what is my y? Y is said to be m of xk plus 1. Okay, minus of yk, that was in my d1, and in my d2 I'll not make any changes to yk plus 1 minus of this y. What is y? Y is actually equal to what? It is said to be m of xk plus 1 plus c, isn't it? So I get it like this. Now when I reduce this equation, I'll get something. I have to open it up. When I open it up, I get it as m of xk plus 1 plus c minus of yk minus of, I'll try to solve this part first, that is yk plus 1 minus of m of xk plus 1 minus of c. Okay, I hope this much is clear with everyone. Again, when I open the brackets, I'll get m of xk plus 1, okay, plus c minus of yk plus 1, okay, minus becomes plus m of xk plus 1 plus c, which if you see, I can write it as, if I remove these brackets, here, this is minus yk and this becomes minus 1, so I have one term of m of xk plus 1. I also have one more term of m of xk plus 1. So I can write it as 2 times m of xk plus 1. Okay. Then I have two terms for my c. So I can write it as plus 2c. Okay. Then I can see that I have two terms for my yk. So I can write it as minus of 2yk. Okay. Then I have only a single term for 1, that is said to be minus 1. Okay, I've got single term of 1, that is I've written like this. Now once I've got this equation, that I've got, I hope everybody has seen this equation. In this equation there is a problem. What is the problem? The problem is my m. Always remember what is m. M is what? It is the distance, it is the difference between the y value and the difference between the x coordinate value. So when I take my slope, there is a division operation which takes place. And whenever a division operation takes place, it always results into a floating point value. It will always result in a floating point value. And I do not need this floating point value. So what do I need to do? So to remove this floating point value, I'll just write it once again, what my d1 minus d2 is. What is my d1 minus d2? It can be written as 2 times m of xk plus 1. Okay, then I had a term which was 2c. I had minus of 2yk and I had a minus 1. I think that is correct. Isn't it, everyone? I hope that is correct. Okay, so now I already told you I have a term m. So I'm going to substitute the value of m, that is delta y by delta x. Then I write xk plus 1 plus 2c minus of 2yk minus of 1. Now if I have to remove this fractional part, I need to multiply what value? Delta x on both sides of my equation. So what do I get? I'll get it as delta x into d1 minus d2. I'll get delta x into d1 minus d2, which is equal to delta x into 2 times delta y by delta x, that is xk plus 1, plus I have 2c minus of 2yk minus of 1. Now when I multiply my delta x with each component inside my brackets, this will be 2 delta y, because this delta x and this delta x gets cancelled, and I'll get xk plus 1. Then delta x is multiplied with 2c, so I'll get it as 2 times delta x of c. Then delta x is multiplied with this term, I'll get it as 2 delta x into yk minus of delta x. I'll get it as minus of delta x. Now what I'm going to do is, I'm going to open up this bracket also. Okay, I'm going to open up this bracket also, such that I'll get it as 2 times delta y xk plus 2 delta y plus 2 delta x. Remaining part I'm going to write. Okay, delta x yk minus of delta x. Now what I'm trying to do is, I'm going to bring the xk and the yk term together, because that are the these are the two things which are going to make changes, isn't it? So I'll bring those two values together. So to delta y xk, I'm just rearranging this. This minus of 2 delta x yk. And what about the other values? That is 2 times delta y plus 2 times delta xc and my minus of delta x. So this is what I get finally. Okay, so when I get this finally, what do I see here? I can see that my d1 minus d2, okay, that is actually, you can call it as a decision parameter. You can call it as a decision parameter which decides whether I need to take the yk value or I have to take yk plus 1 value, which value I have to take. So that is dependent on my decision parameter. Now this decision parameter basically depends, it keeps varying. The value, this particular, the left hand side value will always vary on the basis of the value of your xk and yk. It will vary on the basis of the values in your xk and your yk. Okay, so these are the two components which are very important in this equation of mine. But if you see the remaining part, you will never have a change in your difference in y value, your difference in x value, you have a constant value. So this much part of your equation is said to be constant. This expression that you have got here, this is going to be constant here. The only varying part is these two. So what do? I try to eliminate this part. Okay, I try to eliminate this part and keep my decision making value simple. That is, it is dependent on 2 times delta y on xk minus 2 times delta x into yk. So this is what is going to be my final equation on which my decision parameter is going to depend on. Now, if you see the left hand side, it is quite long, isn't it? Delta x into d1 minus d2. So instead of using this long term, I can use a new name for this. I can use a new name which is said to be called as pk. It is said to be called as pk. So I have derived my decision parameter pk, which is actually depending on twice the difference value of y into xk minus twice the difference value of x into yk. I hope this much is clear to everyone. So this is the main thing that I need to derive. Okay, so you have to know you will have to know how to derive the decision parameters. Okay, to derive the decision parameters, first of all, what do you need? You need to find the point y, okay, which has a distance of d1 from the point yk, and it has a distance of d2 from the point yk plus 1. And how do you find y's value? Whether is it going to be yk or yk plus 1? It depends on the distance value d1 and d2. If your d1, the decision you can say d1, if it is said to be less than your d2, then the value of your y is going to be equal to yk. If your d1 is said to be, d1 is less than d2. If d1 is less than d2, and if your d1 is greater than d2, obviously the d2 is having a lesser value, so y is going to be yk plus 1. Okay, so that is how we decide. So the decision parameter here is said to be your distance. So how do you find that? We normally do d1 minus d2. And then we see whether this particular difference value is said to be less than 0 or greater than 0. And for that, I need the slope of my line. I plot it with the first point, that is xk, yk. And then I find what my d1 equation is, what my d2 equation is. In my d1 and d2, I replace the value of my y. Okay, I replace the value of my y. And there is a slope component which always tries to bring in floating point values. I need to avoid the floating point values. If I have to avoid the floating point value, m has to be replaced by delta y by delta x. Okay, so m has to be replaced by delta y by delta x. And I need to remove the denominator, okay, because of which the floating point concept comes in. To remove the denominator, what do? The simplest thing is both the left hand side and the right hand side of my equation are multiplied by the denominator value. That is, I multiplied it by delta x. After multiplying by delta x, I can see that there's a small modification which takes place on my right hand side. I have written on that basis. After that, I'm segregating my elements in my equation on the basis of varying elements and the constant elements. Now, in the case of my decision parameter, I don't want my constant elements to be used again and again because it is always going to give the same value. So that doesn't make any much change in my decision parameter. So people, the things, the elements which are making change, that is xk and yk, they are the main components in my decision parameter. So I only retain those two values. This delta x into d1 minus d2 is something which is very long to always use. So instead of using this particular term, I am going to use a simple term which is said to be called as pk. So I hope you have understood how to derive the value of pk. Now once we are clear with how to derive the value of pk, that is the decision parameter at one particular point. So I have found the decision parameter at this particular point. Now, obviously, my line is not coming to an end here, isn't it? It's going to extend. So when it extends, I need to find the decision parameter for the next point. I need to find the decision parameter at the next point. So how do I find that? That is what we are going to see. To find the decision parameter at the next point, I'll call the decision parameter as P next. I can call the decision parameter as P next. So I already have my pk. I called it as the pk was 2 times of delta y into xk minus of 2 times of delta x, and you can just remember, if it is y here it is going to be x, if it is x here it is going to be y. Okay, so yk. So that is how you can remember. So I've got my pk. Now I need to find what my p next value is. To find my p next value, I can just substitute it as in this equation itself. I can write it as 2 times delta y. This is not going to change. Your xk, I'll call it as x next. It is going to be replaced by the value which is next x. And your y can be replaced by, you can say that also x next. Okay, that also I can call it as x next. Now, if I have to compute p next, what value should I add to pk? What value should I add to pk so that I'll get my next value, that is p next? How do I find that? Okay, so if I have to compute every time when I draw a line, at each point of it, I'll have to compute my decision parameter, which is said to be pk. So once I have found the first initial, I have found a decision parameter, by what value should I increment or decrement it, or so that I get my next parameter value. So to find that value, the difference value between these two, I have to find the difference between these 2 points. That is p next minus pk will give me the value by which my pk has to be updated so that I can get my p next. Okay, I hope you have understood this. So when I write this, I can I can just substitute p next value as 2 times delta y of x next minus 2 times delta x of y next. Okay, that was my p next. I'm going to subtract from it the pk value, that is 2 times delta y of xk minus of 2 times delta x of yk. I've done this now. Now what I can do is I can just open it up. I'm going to open it up, and that is going to give me 2 times delta y x next, okay, minus 2 times x of y next, delta x of y next, minus of 2 times delta y of xk plus 2 times delta x of yk. I've got this. Okay, now when I look into this, what do I see here? What is my x next? I know what my x next is. For sure, I know what my x next is. That I know it is going to be xk plus 1. It's going to be my xk plus 1. Okay, but I do not know what my y next is. I do not know what my y next is. So there are so many terms here. I'll try to bring some terms together. I've got 2 delta y here. I've got some 2 delta y here. I've got 2 delta x here. I've got 2 delta x here. So I'm going to group some terms together. I'll take 2 delta y as common, and I can write it as x next. Okay, and minus of xk. Okay, then I take minus of 2 delta x, and I can write it as y next minus of, because here as it is minus, so minus plus is going to be minus of yk. So I have deduced my p next minus pk as this particular equation. Now again this p next minus pk, okay, this p next minus pk, that is my updation value. My updation value can have a value which is less than 0, or I can have my p next minus pk value to be greater than 0. It can be less than 0, it can be greater than 0. I said that pk has to be updated by some value. Okay, so as to get the next value, that is p next. I do not know what that value is. For that, I found the difference between p next and pk, and I've come to an equation. But I'm saying that this p next minus pk can have a value which is less than 0, or it can have a value which is greater than 0. So these are the two possibilities that I have. Okay, so as to find the updating value. Now, if this condition is there, that is p next minus pk is said to be less than 0. So, from the earlier point itself, we remember the decision parameter d1 and d2, where I said if my d1 is less than d2, what is my y value? It is going to be yk. If my d1 is greater than d2, what is my y value? It is going to be yk plus 1. Same applies here. If my p next minus pk is said to be less than 0, I can deduce that as pk is something which is made up of, pk is derived from which value? What is my pk? It is derived from d1 minus d2, isn't it? What is my pk? Pk is actually, it is delta x of d1 minus d2. If my d1 minus d2, when I do the difference, if it is said to be less than 0, my y value is going to be yk. Okay. If I take my px is equal to delta x of d1 minus d2, and my d1 minus d2 is said to be having a value greater than 0, that means obviously d2 is said to be having a value greater than d1. That means y is going to have the value yk plus 1. Okay, so that is what indirectly is being shown here. So when I have my p next minus pk is less than 0, that means I can say that the y value is going to be yk. Okay, my y value is going to be my yk. So how do I write this? How do I find the equation of my p next? So what is the value of my p next? P next minus pk is actually equal to 2 times delta y of x next minus of xk minus of 2 delta x y next minus of yk. Okay, I'm taking the first case. Okay, I'm going to talk about the first case. So in the first case, in my first case, I'm saying that p next minus pk is resulting into 0. That means I'm going to have my y value is equal to my yk. So that means my y next, the new value of my y is going to be yk. So where I see my y next, I'll replace it by yk. So I can write that p next, I'm going to take my pk to the right hand side. So it becomes pk plus 2 delta y. Obviously your x next value, I told you it is going to be xk plus 1 minus of xk, which is already there, minus of 2 delta x. What is your y next? Y next is equal to yk. I've written yk minus of yk. Okay, so what do I see here? Yk minus yk is going to be 0. Okay, then xk and xk gets cancelled. So I can write it as equal to the original value pk plus 2 delta y into 1. So it is going to be 2 delta y. So minus of 2 delta x into 0. So this part is going to be 0. So I'll get it as minus of 0. Or you can write it as pk plus 2 delta y. pk plus 2 delta y. Okay. Now that was for my p next minus pk, which is said to be less than 0. Okay, it is for my p next minus pk, which is said to be less than 0. Now let us look for this particular part. For this particular part, what will I have? Don't have much space. So I'm going to write my p next minus pk is said to be greater than 0 condition. That is my second condition. I know that p next minus pk, I had derived it as the equation that I derived it as, it is coming as 2 delta y. Okay, x next minus of xk, and then I had minus of 2 delta x into y next minus of yk. Obviously not minus, it was actually plus, isn't it? It was plus. Okay, now that I've got this particular value, I think it was minus. So then after that, I had, okay, now when your p next is said to be greater, p next minus pk is greater than 0, that means you're going to have your y value to be equal to yk plus 1. Okay, you got to have your y value to be yk plus 1. So I can substitute it as 2 delta y, and in the x next I'll write it as xk, it is xk plus 1 minus of xk minus of 2 delta x. What is your y next? It is yk plus 1 minus of yk. Okay, so that is equal to, I can say that xk and xk cancels here, my yk and yk cancels here. I'll have 2 delta y into 1 minus 2 delta x into 1. I forgot to bring my pk to the right hand side. Now I bring my pk to the right hand side. I get it as 2 delta y minus of 2 delta x. That means the new value of my decision parameter, that is p next, or you can say which is said to be pk plus 1, is said to be determined by what is the original value of my pk. With that you have to add the constant value, that is plus 2 delta y minus 2 delta x, in the case where your p next is said to be, p next minus pk is said to be greater than 0. So I'll just summarize that p next minus pk, okay, if it is said to be less than 0, your new value of p next is always equal to pk plus 2 delta y. And when your p next minus pk is greater than 0, in that your p next value is said to be it is dependent on both the difference of your y value and the difference of your x value. We'll continue with this in the next class.